All right, let's talk about something huge. We're going to dive into the two cosmic dances our planet does that literally define our days and our years. I'm talking about rotation and revolution.
But first, let me ask you something. Right now, wherever you are, do you feel like you're sitting still? I mean, really perfectly still. 'Cause, well, I've got some news for you.
Yeah, you're not even close. You are actually hurtling through space on this giant spinning ball we call home. And to really get a grip on all that movement, we've got to start with the basics. You know, the planet itself.
Okay, first things first. Let's talk about Earth's shape. We've all seen that incredible blue marble photo from space, right? But here's the thing, it's not quite as perfectly round as you might think.
So what is the real shape of our planet? We learned in school that it's a sphere, but is that the whole story?
Well, yes and no. It's basically spherical, but it's not a perfect, pristine sphere like a marble. It's got its own kind of unique, slightly squished shape.
Here's how it works. The Earth is a little bit flattened at the north and south poles, and it kind of bulges out around the middle. At the equator, this happens because it's spinning so fast. Think about spinning a water balloon. It gets wider in the middle, right? Same idea. And that funky shape has a fancy name. It's called an oblate spheroid. And hey, we can actually prove this bulge is real. All we have to do is measure the distance all the way around the Earth, its circumference.
And check this out. Here's the proof right here. If you measure the distance around the equator, it's actually longer than the distance if you measure around the poles. So that bulge in the middle, totally real.
All right, so now that we know the shape of our planetary dance floor, let's get into its first big move, the daily spin.
This move is called rotation. It's just the Earth spinning on its own axis. Now, this axis isn't a real pole you can touch. It's an imaginary line that goes right through the North and South poles. Just picture a spinning top. That's basically what our planet is doing all the time.
And how long does one of these full spins take? You already know this one. It takes 24 hours. That's what gives us one full day.
And this is so important. This constant spinning is what gives us day and night. Think about it. As the Earth turns, different parts of it face the sun. When your side is facing the sun, hey, it's daytime. When it spins away from the sun into its own shadow, you've got night. It's that simple, but it's also what our entire daily rhythm is based on.
But that daily spin, that's only half the story. While our planet is doing its 24-hour twirl, it's also on a much, much bigger journey through space.
And we call this epic journey revolution. This isn't about spinning in place. Nope. This is the Earth moving along a giant path, what we call its orbit, all the way around the sun.
And how long does it take for Earth to do one full lap around the sun? A whopping 365 days.
Yep, that one complete journey is what we call a year. So every time you celebrate a birthday, what you're really celebrating is that you've just finished another full trip around the sun on this amazing spaceship called Earth. Pretty cool, right? Okay, so let's put this all together. We've got these two major movements happening at the same time, all the time. Let's put them side by side so it's super clear.
This really breaks it down, doesn't it? On one side, you've got rotation. That's the spin on the axis. It takes 24 hours, and it's why we have day and night. On the other side, you've got revolution. That's the big orbit around the sun. That takes a whole 365 days, and it's what gives us our year. Two pretty simple ideas, but they shape everything about how we experience time.
So when you think about it, our most fundamental ways of measuring time, the day, the year, they aren't things we just made up. They come directly from these two incredible cosmic motions, our planet's daily spin and its annual journey through space. But that leaves us with one more really interesting question, doesn't it? If the Earth's spin gives us day and night, and its trip around the sun gives us the year, then what gives us the seasons? That's a great question to chew on, and maybe one we'll tackle next time.